Hey folks, how's it going? Mr. Murray coming to you with a quick recap on absolute value inequalities. This is going to cover, again, what is absolute value inequalities. It's going to cover some fundamentals you need to know, and then I'm going to recap the homework assignment that was supposed to be done for today's class. So by the end of this video, the entire front of handout 4.9, 2020-2021 should be completed. Okay, so to jump into it, an absolute value inequality, let's recall that it is an inequality that contains an absolute value. I know, not the most creative example of a definition. Types of solution sets you can see on the right. So more or less, it's going to break down into 4 different solution types. Again, remember how in class we did not discuss the possibility of having 0 on the other side, so we only discussed a positive and a negative number. We also noted that if it was greater than or equal to, for these types of solutions, it's not going to have an impact. Again, 0 on the right side, that could be a complicating factor. So we're only going to focus on bigger than a negative or bigger than or equal to, less than or equal to a negative, or bigger than or equal to a positive, or less than or equal to a positive. In other words, what you see in this top right box here. So we talked about how only when the bars are alone, and again, just like with equations, the bars have to be alone to be able to make any kind of conclusion here. If we're greater than or equal to a positive number, that's going to be associated with an or inequality. If we're less than or equal to a positive number, that's going to be related to an and inequality. If we're greater than or equal to a negative number, all real numbers will make the inequality true. And if we're less than or equal to a negative number, then we have no solution. Another thing we talked about in class, remember how with an equation, if we're equal to a negative number, it's always no solution. Again, assuming the bars are alone. This is not necessarily true with an inequality. So again, we have to remember that an absolute value represents distance, and distance can only be 0 if the two numbers are, in the same exact place. They're no units away from each other. Or if we have a situation where we have a positive, right? You can either be a positive or 0. Okay, in the bottom left, this is going to look different because A period and C period, we did some different examples. This is on the bottom left, an example of an inequality. And on the bottom right, you have a graph. And so what we looked at is, as you can see here, we have a V, our absolute value graph, representing the absolute value of x minus 1. And we have a horizontal line representing 2. And we can see that the absolute value graph is either at the blue line or below the blue line from x is equal to negative 1 all the way up to when x is equal to 3. So that gives rise to an and inequality. You can think about how if I had said the absolute value of x minus 1 is greater than 2, how that would split into the numbers that are either less than negative 1 or more than positive 3. So 2 disconnected intervals representing an or inequality. Okay, so remember that the solving absolute value equations and inequalities comes down to 3 fundamental steps. 1, you have to get to bars alone. You have to get the bars alone. And the way you get the bars alone is the same way as you get any variable alone. You just get all the stuff to the right of the bars to go away by either adding or subtracting, and then you get the stuff in front of the bars to go away by multiplying or dividing. You do not distribute into the bars. You do not add anything inside the bars. You do not do anything to what is actually in the bars itself. Do not touch them at all, okay? You get the bars alone. 2, you're going to determine the solution type. So we talked about for an equation, are we going to have 2 solutions, 1 solution, or no solutions? With an inequality, are we going to have an and inequality, an or inequality? Are we going to have greater than, or are we going to have like no solutions or infinite solutions, all real numbers, essentially? Okay. And then the last one is solve whatever equations or inequalities are necessary to be able to finish up solving the equation or inequality. And so at that point, and you see I made a note here, once you get to that third step, your bars are gone. You've taken the bars off and you're just solving for x. You're getting x alone. Okay? So we saw this last time, and again, if you're period A or period C, these steps on the left look not necessarily exactly the same, but they're basically the same idea. Again, getting the bars alone, determining what kind of solution type you have, and inequality or inequality, all real numbers, no numbers at all, and then solving the necessary inequalities. So we solved these first two on the left in class. I'm going to go ahead and solve the next two. So the first step here is to get the bars alone, and to get the bars alone, I'm going to multiply both sides by -2. -2 will cancel out, and I'll have x minus 6. Now, one thing to remember is because I multiplied by a negative number, I need to go ahead and I need to flip the direction of the inequality sign. Okay, remember how we talked about in class, negative numbers work different than positive numbers. So -6 is actually greater than -7. But +6 is actually less than +7. So what's bigger and what's smaller, what's greater than and what's less than, works differently when you're in the negatives versus when you're in the positives. When you're in the negatives, being greater than means you're closer to 0. You're less negative. When you're in the positives, it means you're further from 0. You're more positive. Okay, so again, you really need to make sure to flip the sign of the inequality whenever you multiply or divide. Only when you multiply or divide by a negative number. If you add a negative number or subtract a negative number, there's no impact at all. It's only when you multiply or divide by that negative. So we have x minus 6 absolute value is less than -12. So we're going to ask ourselves, what numbers, when I take them away from 6, are going to have an absolute value that's less than -12? And we remember that absolute value has to either be positive or 0. Meaning it will always be greater than -12. That is, there's no way to have an absolute value that's less than -12. So therefore, there are no solutions, or in a set notation, you can write it like this, the null, a 0 with a line through it. Because no numbers, when I take away 6, are ever going to yield an absolute value that's negative, much less than -12. All right, last step, what I'm going to do, I'm going to take a look here. I'm going to divide by 3 to get those bars alone. So I go x minus 10 in the bars, less than or equal to 3. Now I am in bars alone. So now I'm going to ask myself, what numbers, when I take away 10, could have an absolute value that's less than or equal to -3? So I could say, all right, 13. Well, when I take away 10, I get 3. That absolute value is greater than 3. I could have 12. When I take away 12, it's absolute. When I take away 10 from 12, I get 2. That absolute value is 2, less than 3. I could do 10. 10 minus 10 is 0. The absolute value there is 0, which is less than -3. I could even have a number like 8. When I take away 8, 10 from 8, that is, I get -2. That absolute value is less than 3 because the absolute value there is 2. I could have 7. 7 minus 10 is -3, whose absolute value is equal to 3. I could not have 6, though, because 6 minus 10 is -4. That absolute value is not less than -3 because it is 4. That's greater than 3. So I need, whenever I take away 10, I have to have a number that's greater than or equal to -3 and less than or equal to +3, okay? So that way, when I take the absolute value of x minus 10, I get a number that is less than or equal to 3, okay? So only the x's that are in this interval are going to work. How do I solve this? I'm going to add 10 to all 3 parts. Remember, when you solve an and inequality, you're going to add 10 to all three parts. So negative 3 plus 10 is 7. Remember, that was the lowest I could go from our little thought experiment there. And then the highest we can go is 13. So that is our solution. As an interval, because this is or equal, you would do hard bracket 7, 13, close the hard bracket. Okay, you can also notice those are the numbers that are within 3 units of 10, right? 7 is the lowest you can go, being 3 units from 10, and 13 is the highest you can go, being within 3 units of 10. Okay, so the big takeaway, just remember, and this is, again, one of the biggest mistakes people make, when you multiply or divide both sides of an inequality by a negative number, you must flip the direction of the inequality sign. Okay, so if it's less than, it goes to greater than. If it's greater than, it goes to less than. If it's or equal, you leave it or equal, but you need to remember to flip the direction of that inequality sign whenever you multiply or divide both sides of an inequality by a negative number. All right, so in today's lesson, you're going to go ahead and we'll work together to finish up the back side of 4-9. Be on the lookout for that separate video link. Thanks so much, guys. Hopefully this went well and you're ready to talk about it when we come back together in person. Keep it up, folks. Best of luck with all your learning, and remember that you can do it. All right, folks, until next time, have a wonderful day, and don't forget to love math.